Welcome to Rational Expressions, lesson number 2. Today we are concentrating on simplifying a rational expression. First thing we need to remember from elementary school math classes is that we can multiply and divide a number by 1 and it doesn't change the value. So we can also do the same thing to a rational expression. So let's look at just a rational number. If we take the number 3 and I multiply it by 2 over 2, 2 over 2 is equivalent to 1, so I'm not changing the value. Well, let's confirm this. Well, 3 times 2 is 6 divided by 2, which we also know that 6 divided by 2 is 3. So I did not change the value of 3 at all by multiplying by 2 divided by 2. Let's take another example. 9 divided by 12. How was that changed? Well, let's see. I know that 9 is the same as 3 times 3. I also know that 12 is the same as 3 times 4. Well, from this, I can see that 3 and 3, 3 divided by 3 is 1. So that means my final answer, if I simplify it down, of 3 over 4 hasn't changed. So 9 over 12 is equivalent to 3/4. Again, because of the 3 divided by 3, which is 1. Let's take m cubed times t divided by m squared times t to the 4th. Well, I need something in common like I had with the two 3's in the previous example. So at first I'm going to say, okay, well, I have an m squared on the bottom, so I'm going to change m cubed to m squared times m times t. So I have an m squared on the bottom. Well, what happens to my t to the 4th? Well, I know I need a single t, and I have t cubed. Now, that gives me a couple of things. I have m squared, that's 1. I have t and t, which is also 1. So that means, simplified, m cubed t is equivalent to m on the top, and then m squared t4 is equivalent to t cubed on the bottom. So now m cubed t divided by m squared t to the 4th is equivalent to m divided by t to the cube. Now the only difference between my first two examples and my third example is on the third example I actually have two factors on the bottom where I have two variables. I have a variable of m and I have a variable t. So from lesson number 1, I have to state my non-permissible values. So I know that m squared, set it equal to 0. Take the square root of m squared, square root of 0, so m equals 0. So m cannot equal 0 is my non-permissible value. And then let's look at t to the 4th equals 0. I'm going to take the 4th root of t to the 4th, and I'm going to take the 4th root of 0. So I know that t equals 0. So t cannot equal 0 is my non-permissible value. Now, why do I state that? Because I had two variables on in the denominator, I have to state the non-permissible values. Always. Because we have to make sure that our variables are never, whatever number we put in, cannot make the denominator 0. Let's look at our example of 7s divided by s minus 2. And say I asked you to multiply by s over s, so which is equivalent to 1. Well, I've been given that s cannot equal 2 as my non-permissible value already. Great, that saves me a step. But with s over s, I also have to be able to state that s cannot equal 0. Because if it did, I would have 0 on the bottom, and that would render my fraction undefinable. So you're saying, well, but 0 over 0 is 1, so where are you going with this, Miss Carla? Well, I'll show you. So let's take 7s over s minus 2, and I'm going to multiply by s over s. So that's 7s times s divided by s minus 2 times s. Oh, now I see, Miss Carla, because I have s here, and if it's 0, my whole expression on the bottom is 0, so that's an undefined number. And s minus 2 is what they've given me already, so I can't have 2 minus 2, because then that creates 0. So s squared, 7s squared over s squared minus 2s is equivalent to 7s over s minus 2. I have created an equivalent expression by multiplying by s divided by s. Now, if you are asked to show that two expressions are equivalent, we have to sort of do some factoring and figure out which way where that 1 came from, just like I did with the 9 over 12. So I have 7s and s minus 2. And they're asking me, how is that equivalent to 7s times s plus 2 over s minus 2 times s plus 2? Well, oh, look at this. I have 7s and 7s, yep. S minus 2, those two are the same. But I have an s plus 2 divided by s plus 2. Oh, I can isolate that out. So I can take 7s over s minus 2. Isolate out my s plus 2 divided by s plus 2. That's 1. That equals 7s over s minus 2. Well, that's what I wanted to start with in the first place, so I know that those two are equivalent. And yes, they've given us our non-permissible values already. When a rational expression is in its simplest form, or its lowest terms, the numerator and denominator have no common factors other than 1. So when we're asked to simplify, you have to make sure that you are moving everything into its simplest form. So let's look at the next two examples. We're asked to simplify each and state the non-permissible values because they haven't been given to us already. So let's take the first one, 3x minus 6. Well, I have a polynomial in the numerator, and I have a quadratic in the denominator. With the polynomial, is it in its lowest terms? No, it's not, because I have 3 common to 3x and 6. So I'm going to take that out. So I have 3 times x minus 2. Let's look at the quadratic. I have 2x squared plus x minus 10. So I'm going to factor this. I have 2x. What multiplied together makes minus 10, but adds together to make plus 1. 4 and 5? Well, okay, but how am I going to make a 4? Well, with a 2, because 2 times 5 is 10, but then 4 plus 5, if there's a negative in there, I can get a 1. So I have 2x plus 5, because I need to have the bigger number as a plus, and x minus 2. So if we FOIL, we get 2x squared here, and then I get minus 4x plus 5x, that gives me plus 5. And of course, 5 minus 2 is 10 from FOIL. Now, I haven't finished breaking it down to its lowest terms because I have x minus 2 and x minus 2. So I know I can cross those two out. So that leaves me with 3 over 2x plus 5. But now I have to state my non-permissible values. I'm going to go back to this line because once I've broken my quadratic down into the individual factors, I can actually pull out my non-permissible values. So if I take my two factors, I have 2x plus 5 equals 0, and the second one is x minus 2. Now I can solve for x. So 2x plus 5 equals 0. I have x equals minus 5 over 2. So that's one non-permissible value, minus 5 over 2. Let's look at my second factor of x minus 2. Set that to 0, solve for x. X equals 2. 2 is my second non-permissible value. So now I have simplified. There's my simplified rational expression, and I've stated my non-permissible values. Let's do one more before you do a couple on your own. I have 1 minus t divided by t squared minus 1. So again, I have a polynomial. And I have a quadratic. These ones just happen that I have polynomials both on the numerator for both these examples. But I could have had a quadratic. You would follow the same steps for the quadratic as I'm going to do on the denominator. Okay. So I have 1 minus t divided by, well, my quadratic is a perfect square. So I'm going to factor that out. I have t minus 1, t plus 1. Well, hang on. I got 1 minus t here in my numerator, and I have a t minus 1. Is there something I can do to my numerator to make it look like t minus 1? Yes, there is. I can take out a negative 1. So I'm going to do that. So then I end up with t minus 1 in the numerator, and I have t minus 1 in the denominator and t plus 1. So now I have two things that I can cross out, t minus 1 and t minus 1, and my answer becomes minus 1 over t plus 1. So again, I need to state my non-permissible values. So I'm going to go back to when I factored my quadratic. So t minus 1, t plus 1. So let's take the first one, t minus 1 equals 0, t equals 1. Let's take the second one, t plus 1 equals 0, t equals negative 1. So my non-permissible values are x cannot equal plus or minus 1. I have simplified and stated my non-permissible values. You try the next two on your own